Hello everyone. In this video we are going to start reviewing the problems from our very first test from Math 171 WA. In this first video we're going to take a look at the first half of the test, which covered problems from Chapter 1. So let's start with the very first problem. We were given the equation 3 over x plus 2 subtract 2 over x minus 1 equals x subtract 6 over x squared plus x subtract 2. And the instructions asked us to solve the equation, that the answers must be exact, that we should show our work, and write the solution as a solution set. So let's take a look at this. Because this equation involves rational expressions, the first thing we need to do is figure out what the least common denominator is for the equation. So we see on the left-hand side denominators of x plus 2 and x subtract 1. And if we look at the right-hand side and we factor x squared plus x subtract 2, we see that that factors as x plus 2 times x subtract 1. So the product of those two binomials is our least common denominator. That also tells us what our restrictions are on our solution set. Because x plus 2 and x minus 1 both show up in the denominators of fractions in our equation, that means that any numbers that zero out these two binomials are not possible solutions. So we know right away that x is not allowed to equal negative 2 and x is not allowed to equal positive 1. So those are our restrictions. Now that we have the restrictions on our solution set, we should multiply by the LCD to clear the fractions from the equation. Now, be very careful when you write this out. You do not want to put parentheses around the entire equation and only write the LCD once. That is very incorrect notation, so don't do that. If you want to show that you're going to multiply, then what you want to do is write down your LCD on the left-hand side, open a set of parentheses for the left-hand side of the equation, close the parentheses, copy down the equal sign, write down the opposite side of your equation, and show multiplication by the LCD again. So this is what the correct notation looks like when you're going to multiply by an LCD. So now we'll actually do the multiplication. When we take the right-hand side and multiply, of course, the LCD cancels the entire denominator. So this cancels both of these factors. Now, we have to be careful over on the left-hand side, because this time we have to use the distributive property. So when we distribute to the first half of our difference, the x plus 2 will cancel, leaving us with 3 times x subtract 1. And then finishing our distributive property, in the next term, the x subtract 1 will cancel, leaving us with 2 times x plus 2. So we are now left with the equation 3 times the quantity x minus 1 subtract 2 times the quantity x plus 2 is equal to x subtract 6. We still have parentheses, so that means we need to distribute again to clear the parentheses from the problem. So we'll have 3x subtract 3, and here be careful, we're distributing negative 2, so that will be minus 2x subtract 4, and then of course on the other side we still have x subtract 6. Now our job is to combine like terms. So on the left-hand side we're left with x subtract 7, and on the right-hand side we have x subtract 6. Continuing on, we see that the x's will cancel each other out. We have x minus x, and that our constants will not. We have negative 6 plus 7. So we end up with 0 is equal to 1. Of course, this is not true that means that we have no solutions to this equation. So to write that as a set, we have two choices. We can write the symbol for the empty set, which looks like this, or we can open our brackets for our set notation and leave the interior of the brackets empty. So either of those two symbols would be the correct answer for writing down an empty solution set. Now, part B in the problem asked us to determine whether the equation was inconsistent, conditional, or an identity, and to explain the answer in a complete sentence. Because there are no solutions, that means the equation is inconsistent. So we would want to write a sentence something along the lines of the equation is inconsistent because it has no solutions. Now, one important little thing I want to point out about this sentence. Notice it says no solutions. That means no solutions whatsoever. If you insert the word real in there, then you don't quite have the right answer. We can have solutions to equations that are non-real. So if I solve, for example, a quadratic equation and I get a pair of complex roots, then that particular equation is conditional. It does have solutions. They're not real solutions, but they are solutions. So the important thing here is that there are no solutions at all of any type to the equation. Now let's take a look at the second problem. We're given the ordered pairs 0, 16 and 4, 8 and asked to do two things: to find the exact distance between the points and to find the exact coordinates of the midpoint of the line segment that would join the 2 points. So let's start out with the distance between the 2 points. What we need to do here is fill in our distance formula. So for our distance formula, first we need to find the difference in the x coordinates of the two ordered pairs. So that would be 4 subtract 0. And then we're going to square that difference. Then we need to do the same thing with the y coordinates. So we're going to take 8 and subtract 16 and square that difference. Then we sum the results, and then we take the square root. So when we look in here, 4 minus 0, of course, is 4, and 4 squared is 16. And then we have 8 subtract 16, which is negative 8. We square that and we get 64. So we have 16 plus 64 underneath of the radical. Well, in this particular case, we can factor out a square root of 16. And when we do that, that's going to leave 1 plus 4 underneath the second radical. So we have the square root of 16 times the square root of 5, and of course the root of 16 is 4, so the exact distance between the two ordered pairs is 4 square roots of 5. For the midpoint, we need to average the x coordinates and average the y coordinates. Remember, that's what an average is the middle between something. So for our midpoint, we're going to take 0 and 4, our two x coordinates, add them together and divide by 2 to find the center. And then we'll do the same thing with our y coordinates. We'll take 16 and 8 and add them together and divide by 2. So that means we have 4 divided by 2, or 2 for the x coordinate of our midpoint, and then we do the same thing with our other coordinate. 16 plus 8 divided by 2 is equal to 12. So the midpoint is the ordered pair 2, 12. In problem number 3, we are given the ordered pairs 3, 6 and 9, 24 and asked to do three things: to write the point-slope form of the line connecting the points, to write the slope-intercept form of the line connecting the points, and to write the standard form of the line connecting the given pair of points. So let's start out with the point-slope form. To write the point-slope form of a line, we need to know two things. We need to know a slope, and we need to know a point. So let's start by calculating the slope. So remember, slope is change in y divided by change in x. So the change in the y coordinates is 24 minus 6, and the change in the x coordinates is 9 subtract 3. 24 minus 6 is 18, and 9 minus 3 is 6. And now we divide 18 by 6, and that tells us our slope is 3. So now to get our point-slope form, we simply take one of our ordered pairs and our slope and plug into the point-slope formula. So I'm going to use 3, 6. So I take y and subtract the y coordinate of my point, y minus 6, is equal to slope, that's 3, times the quantity x minus the x coordinate of my ordered pair. So I have y minus 6 equals 3 times the quantity x subtract 3. I could also write y minus 24 equals 3 times x subtract 9. Either one of these is an equally correct point-slope form for the equation of our line. Now, let's take a look at the slope-intercept form. The slope-intercept form is the one way we can write the line that is unique. So that means we want to get our equation in the form y equals mx plus b, where m is our slope, and then b is the y coordinate of our y-intercept point. So I'm going to start with my y minus 6 equals 3 times x minus 3, and rearrange it into the proper format. So I need to distribute my 3. So I now have y minus 6 equals 3x subtract 9, and now I add 6 to both sides. Y equals 3x subtract 3. So this would be my slope-intercept form. And finally, we're asked for the standard form for the equation of our line. For the standard form, we need something of the form ax plus by is equal to c, where a, b, and c are not fractions. So I'm going to rearrange my slope-intercept form into the standard form. So first, I'm going to go ahead and move y to the other side of the equation. So now I have 3x minus 3 subtract y, and of course I need to get the 3 moved as well. So now I can write 3 is equal to 3x subtract y. Of course, you could also move things in the opposite direction, which would give you y subtract 3x is equal to negative 3. Either of those two would be a correct standard form of the equation. In problem number 4, we're asked to simplify some expressions involving the imaginary unit I. So in the first part, we're asked to multiply 4 subtract 5i times 4 plus 5i. So looking at this thing, we can see that these are a conjugate pair. So that means we need to take the 4 and square it. So 4 times 4 is 16. And take the 5i and square it, so that's 25i squared. And then find the difference. But 25i squared is minus 25, because I squared is equal to negative 1. So we're actually adding 16 plus 25, which is equal to 41. In the second half of the problem, we're asked to simplify I to the 28th power. So note that 28 is a multiple of 4. It's 4 times 7. So we can rewrite I to the 28th as I to the 4th raised to the 7th power. I to the 4th is equal to 1, and 1 to the 7th power is equal to 1.